Okay, so this is the continuation of the last topic, path difference, and based on path difference, we try to calculate the phase difference. We try to calculate the phase difference. Okay, so for phase difference, it is necessary to know the relation between the path difference and the distance between transmitter and receiver. So if you imagine it, the distance between transmitter and receiver increases, then this d double dash is approximately equal to d dash. This d double dash is approximately equal to d dash, and these are approximately equal to d. These are approximately equal to d. Means all the distance became same when you increase the distance between transmitter and receiver. Keep in mind. Means the path difference decreases. As the path difference decreases, this d double dash means the distance covered by reflected signal and distance covered by line of sight signal are becomes equal. Okay. Now here, once the path difference is known, means delta is known, phase difference. So phase difference is denoted by theta delta. Phase difference is denoted by theta delta between two electric field. Phase difference between what? Phase difference between electric field of line of sight and electric field of reflected signal. So that is denoted by theta delta, and it is written as theta delta is equal to 2 pi by lambda into delta. Theta delta is equal to 2 pi by lambda into delta. So what is delta? Delta is the path difference. Delta is the path difference. Keep in mind. We know this lambda. Lambda is the wavelength. Lambda is equal to C by F. Lambda is equal to C by F. So if we put the value of lambda is equal to C by F, this F goes to numerator side, it becomes 2 pi F. And we know 2 pi F is nothing but the angular frequency. So delta as it is, 2 pi F means omega C divided by C. Divided by C. Got it? Yes or no? Got
Yes, sir.
value? How the phase difference between two electric field is written. Got it?
Sir, can you repeat the phase difference?
Okay. Phase difference means the difference between two electric field. Okay. Or it is the angle between two electric field. So we have two electric field. This is, here you can see, this is line of sight electric field, and this one is the reflected electric field. Okay. Now, the time coming at the receiver end of both the electric field is different, because the line of sight is directly come to the receiver, but the reflected signal is incident on any object and then reflected towards the receiver. So the time requirement is different, not equal. Again, when it incident on a particular object, it forms an angle. So incident angle and reflected angle. Okay, that's why there is a phase difference between two electric field. Now we have to find out or we'll find out the phase difference between two electric field. The phase difference between two electric field is directly proportional to the path difference, and it is written as, you can see here, the phase difference is directly proportional to path difference, but the scaling factor is 2 pi by lambda. Okay, so we know what is lambda. Lambda is the C by F. We know lambda is equal to C by F. If we replace lambda by C by F, so that denominator F goes at the numerator side. So at the numerator, it becomes 2 pi F, and we know 2 pi F is equal to omega. Okay, and it is related to the carrier frequency. That's why this omega is written as omega C. Okay, and denominator C as it is. This delta is as it is. So theta delta means the phase difference is equal to delta omega C divided by C. Got it now?
Yes, sir.
Okay. So what it means? The phase difference is directly proportional to path difference. Is directly proportional to path difference, and path difference is directly proportional to height of antennas. Path difference is directly proportional to height of antenna. See the last equation, fourth equation, and it is inversely proportional to distance between transmitter and receiver. Keep in mind. Okay. Now, here we know the total electric field. Total electric field, this equation, this equation. Total electric field is the addition of electric field of line of sight and electric field of reflected signal. And here we can see the total electric field or any kind of electric field is a function of distance and time. Is a function of distance and time. Now here, for simplification, we assume that if the received electric field means the total electric field, total electric field is evaluated or calculated, you can say, is calculated at same time, say T is equal to D double dash by C, means the electric field at the receiver end is calculated at a particular time, and that time is nothing but D double dash by C. Okay. Now, when T is equal to D double dash by C, then what happen with the equation, total electric field equation? It becomes E total D comma T is equal to what? T is equal to D double dash by C. Means T is replaced by D double dash by C. Now consider this equation in front of you. Consider this equation in front of you. This T is replaced by D double dash of C is equal to E0 D0 by D dash. E0 D0 by D dash cos of omega C. What is this T? T is equal to D double dash by C minus D dash by C. Here minus sign minus 1 E0 D0 D double dash cos of omega C. What is this T? T is equal to D double dash by C minus D double dash by C. So here if you observe the second parameter, it becomes D double dash by C minus D double dash by C. It becomes 0, means cos of 0, and we know that cos of 0 is equal to 1. Cos of 0 is equal to 1. So here is the equation. E0 D0 by D dash cos of omega C D double dash minus D dash upon C minus E0 D0 by D double dash cos of 0. And we know that cos of 0 is equal to 1. Hmm? And here, if you see D double dash minus D dash, what is D double dash minus D dash? Can anyone?
Path difference.
Yes, it is nothing but the path difference. See this one. Delta is equal to D double dash minus D dash. So here we replace this D double dash minus D dash is equal to delta, and this bracket becomes delta omega C by C. Can anyone tell me what is this? Delta omega C by C? Hmm?
Phase difference.
It is nothing but the phase difference. This theta delta is equal to delta omega C by C. Okay. That's why this can be written as E0 D0 by D dash into this cos is nothing but the angle. Okay. So this angle of theta delta is the phase difference minus this E0 D0 by D double dash as it is. Now up to this, any problem?
No, sir.
All of you got it?
Yes, sir.
Okay.
Yes, sir.
Now here again I repeat it. This D dash and D double dash. What is D dash? What is D dash? D dash is the distance covered by line of sight signal. What is D double dash? D double dash is the signal or the sorry the distance covered by the reflected signal. Okay. As D increases, okay, read this sentence. It should be noted that as D becomes larger, the difference between the distances D dash and D double dash become very small. Okay, because see this equation, delta equation, as D increases, the path difference decreases. It is inversely proportional. Okay, become very small, and the amplitude of line of sight electric field and amplitude of reflected signal are virtually identical and differ only in phase. One second. Okay, differ only in phase means all the distances becomes same. All the distance, you imagine ते असं मोठं मोठं करून पहा, तर सगळे डिस्टन्सेस तुम्हाला सेमच झालेले वाटतील. ओके, इफ यू इन्क्रीज दॅट डिस्टन्स, डी डॅश इज इक्वल टू डी डबल डॅश इज इक्वल टू डी. ओके, so here we consider all d dash d double dash is equal to d. So E total is equal to E0 D0 upon D. Okay, now this angle, okay, so this angle means cos of, it can be written in terms of real part and imaginary part. Okay, so it becomes cos theta delta plus I E0 D0 by D sine of theta, means cos theta plus J sine theta. It is representation of a phase. It is representation of phase. Cos of theta plus J sine theta. Here the multiplication is E0 D0 by D. See this one. Here the multiplication is E0 D0 by D. And this angle means cos of theta delta is written as cos of theta delta plus J sine or I sine theta delta here. Okay, so these two terms minus E0 D0 upon D as it is. Okay, so from first term and last term, here we take E0 D0 upon D common, inside bracket cos of theta delta minus 1 plus I E0 D0 upon D sine of theta delta as it is. Okay, now it is in terms of cos of theta plus j sine theta. Cos of theta plus j sine theta. Here we, if we take the magnitude of it, so magnitude is nothing but root of real part square plus imaginary part square. All of you know it. Okay, real part square plus imaginary part square. So this one means the first part is the real part and second part is the imaginary part. So if we take the square root and real part square, e0 d0 by d square cos of theta delta minus 1 square plus imaginary part square e0 d0 by d square sine square theta delta. Got it up to this? Yes or no?
Yes, sir.
It's very simple. It's a simple mathematics actually. Okay. Now, if you simplify it, means E0 D0 upon D, uh, if we take out of square root, it becomes E0 D0 upon D from both the real part and imaginary part. So E0 D0 upon D. So inside bracket मध्ये काय राहील मग? Here it becomes a minus b square is equal to काय होईल? A minus b square, a square minus 2ab plus b square. So cos square minus 2 cos theta delta plus 1. One second. You simplify this bracket and sine square theta is as it is. And here we know that sine square theta plus cos square theta is equal to 1. Okay. So if you simplify it, you will get under root of 2 minus 2 cos of theta. If we take this 2 common, then inside bracket, it remains 1 minus cos theta. Okay, so 1 minus cos theta is nothing but 2 sine square theta by 2. It is nothing but 2 sine square theta by 2. So if we simplify it, it becomes 4 sine square theta by 2. So if we remove the square bracket, 2 get outside and sine theta delta by 2 get outside. So here the total magnitude of total electric field is equal to 2 E0 D0 upon D sine of theta delta by 2. Up to this, got it? Yes or no? It's simple mathematics.
Yes, sir.
Okay. Now using equation number 4 and 5. What is equation number 4 and 5? So equation number 5 is phase difference and equation number 4 is nothing but path difference. Here we replace the values only. Ah, so here we will replace this theta delta by 2. Okay. So we know theta delta is equal to 2 pi by lambda into delta. So 2 pi by lambda, we know delta is nothing but 2 ht hr upon d. Okay. So this 2, 1, 2 is shifted to left side. It becomes theta delta by 2. It is equal to 2 pi ht hr upon lambda delta. Okay. So this value, this value is replaced only here. Uh, equation simplifies sine theta delta by 2 is approximately equal to theta delta by 2. Can anyone tell me how it is? Can anyone guess it?
Is phase difference small? That is why half of phase difference is equal, approximately equals to sine of phase difference by 2.
Sine of phase difference by 2. Any other answer? It is simple mathematics. Sine theta by 2 is approximately equal to theta by 2. Put some values of theta by 2 here and take the sine of it.
Sir, when the angle is very small,
Huh?
when the angle is very small,
Then it is possible. Then this condition is true. Is it mean?
yes, sir.
Okay. So it's a simple. You just vary these values. Theta by 2 means if you vary this value and take the sine of it, it is approximately equal to that value. Okay. You just try it. Okay. Now equation 7 becomes 2E0 D0 by D, 2E0 D0 by D, and this theta delta by 2 is nothing but 2 pi HTHR upon lambda D. Okay, here only I replace this value with this 2 pi HTHR upon lambda D. Now, if we take the multiplication of it, then it becomes 2, means this becomes 2 into 2, 4, E0, D0, pi, HTHR upon lambda D square. Lambda D square. Now, you tell me 4 is constant? Yes or no? 4 is constant. Then E0, D0 is, these are the reference values. Then pi is a constant value. HT means height of transmitting antenna. HR is the height of receiving antenna. If once we form a model, this remains fixed. Then lambda is the wavelength, it remains fixed. Only what happened here, we change the distance between transmitter and receiver. Here we change the difference between distance between transmitter and receiver. So here only one variable is there, and that variable is nothing but the d. That's why all remaining components means 4, E0, D0, pi, HT, HR, lambda, all these are constant, and here we take only one value in order to represent all these constant as K. As K. Now the total electric field, magnitude of total electric field is equal to K upon D square. K upon D square. So this is the total electric field received at the receiver end in mobile communication. And this is the proof, you can say, and to find out the electric field at the receiver by using ground reflection or two-ray reflection model. Got it or not? Here also
Yes.
you can see the total electric field is inversely proportional to the distance. Is inversely proportional to the distance. As distance increases, electric field increases. As distance increases, electric field decreases, and as distance decreases, electric field increases. And it is true. It is true. When the distance between transmitter and receiver is less, maximum electric field is there. When distance increases, electric field reduces. Got it? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now I will give you time. Sorry.